Today, since we already had one presentation already from the P2 representing the P2 code project, and we have yet another one coming up in the late evening. I suppose that's the last one. So here we are trying to present more on the application side of things, particularly the IoT development side. And we'll be concentrating on the use case that we implement in the Made Competence Center, relying on the ETSI and NGSI-LD standards. So just a brief about the two use cases that we are hosting in Made Competence Center. The first one is, we call it the healthy operator, where we use adaptive collaborative robot cells, the one you can see on the left hand side, where an operator equipped with some sensors, specifically electromyographic ones, monitor the fatigue levels of the operator in order to basically control the behavior of the collaborative robots. And we have yet another use case where we try to control the production line speed using the stress levels of the operator during the assembly task on the station, which you can see on the right hand side. Now, the motivations of using NGSI-LD and why we went for this specific standard was that when you go into the production floor, the different systems are highly fragmented. So, for example, robots, assembly stations, they will have different standards, different protocols. For example, it could be OPC-UA for robots, it could be ROS2, and a lot of other standards. Plus, when we talk about human-centric, particularly things that involve use of variable sensors, these devices are not particularly meant for the industry, are more, let's say, sports variables. So trying to say interact with different systems and ensuring that they talk to each other properly, we needed some sort of a unified standard to represent all the information flows from these heterogeneous sources in a single language. And this is where P2 code comes as an enabler, which basically relies on ETSI and NGSI-LD standard through the use of Fiverr components as its IoT development backbone. So NGSI-LD by itself, as you can see, the last letters here mean linked data, enable semantic interoperability and context awareness, and in a way help you to, let's say, gather information from and different sources and different protocols into a single unified language, which can be understood and easily interacted with. Moving a little bit deeper into the components that we took from the platform, we specifically use the context controller as the Fiverr or LD context broker, and for drivers we had IoT agents, and for say having times series data, we use the Mintaka component from the Fiverr ecosystem. Moving on to a basic level architecture, you can see all the components that you see in light blue color here represent the components that were taken from the P2 code / Fiverr ecosystem. Whereas the green components are something that were green, and the gray components are something that were developed or were already existing. Specifically the gray ones, some of these are pre-existing, while some of them were developed during the process. So now moving on to the information model that we had to start with, I'll just take an example of the first use case where we monitor the muscle activity in order to assess the fatigue levels. So how it works is that we have an operator who say has some muscle activity and he is wearing some sort of a sensor which I showed you earlier. Uh, the muscle activity, of course, is measured by these sensors, and our fatigue model uses two things. First is the real-time muscle activity and the baseline of the operator in this case in order to achieve at some fatigue level, and which in turn controls the operational state of the collaborative so robot cell. So in terms of the NGSI-LD slash 5R ecosystem, these were represented in the form of entities, and each of which had uh, context data stored in an instance of a context server, which basically represents the semantic annotations of each of the different parameters that you can see inside each of these entities. So in a way, if I call Apple by another name, I still ensure that I am talking about the same thing. For example, if I say uh, if I write apple in Italian language, Male, versus apple in English language, it should mean the same to two different, let's say, machines. So this is where the context server here, so basically, this is the function that it is carrying out. So even if you have two different namings, you can still have, let's say, a common definition of both the uh, naming conventions. And coming to how the platform basically supports integration is the primary way it does so is that it supports multiple industrial protocols. So what that means is that I don't specifically have to write individual components for, let's say, interacting with OPUC, UA, or MQTT or ROS2. So what I do is that if I need to, let's say, onboard a sensor or connect some industrial equipment, some collaborative robots, it is managed simply by means of a couple of post requests made to the specific component that I'm using. So there is almost no development effort, both in connecting the sensors and also in interacting with the databases. If you look back at the architectural diagram, here basically I only, as a developer, I only mainly interact with the Orion LD and the Fiber Mintaka for time series, and both of them have almost identical APIs. So if you're familiar with one of them, it is pretty easy to, let's say, use the other component as well. And furthermore, we do not have any direct interaction with the databases underneath. So I don't need to make any development effort to specifically design something to interact with, to basically store or retrieve data from the database. The brokers and the two components, which is the Orion LD broker and the Mintaka, already do it by default. The only thing that I need from a developer perspective is to maybe configure both of these components to listen to our to specific, let's say, sensors, or to uh, let's say configure the location or the databases that I'm using. And again, since I'm using the unified Fiverr APIs, I can consume the databases uh, without having to basically put a lot of effort in making any development. So for example, there's also some additional say uh, uh, good features. Say for example, if I need to, let's say, change this, trigger a state change in the collaborative cell, I do not specifically need to say write code for that. I can directly create a subscription inside the Orion context broker, and as soon as, for example, the stress level goes above a specific value, um, an HTTP post will, or an MQTT message, depending on the protocol I choose, will be sent to the underlying industrial hardware to change the state. So again, this is even, for example, the subscription itself, it is simply managed by a means of simple HTTP post to the Orion broker. And going on to the final parts of the presentation about lessons learned. Again, from what worked well with this was we were able to onboard multi-vendor physiological sensors. For now, we have tried with the electromyograph, which was from BTS, and the Polar H10, which is from Polar. Uh, and we are able to process data at quite high frequencies, particularly for the EMG sensors. It is 1000 hertz, and the heart rate sensor is relatively lower, which is close to 1 hertz, and depending on what type of data we are getting out of this. And of course, this because we are using the linked data entities, so it ensures that all the data that is flowing from different sources is interoperable and has a common definition. Again, it reduces the development effort, and again we were able to implement this solution in a semi-industrial implementation. By semi-industrial implementation, what I mean is that since we used the facilities of Made Competence Center, they host real industrial equipment provided by different partners. So the the situation is as close to an industrial environment as it is possible. Because again, if we go on to the challenges, we see that, let's say, dealing with say stress states using operator data comes with the problem of GDPR and privacy concerns, uh, which is again something that has not been fully addressed both in literature as well as in industry. So this is something that we look forward to in the future and see how the law and everything evolves around it. And again, if law is on the right side of the picture, we would like to have some sort of a full-scale industrial implementation. Furthermore, we are additionally thinking of adding some more sensors to the uh, sensor data models to the smart data models, particularly EEG, eye trackers, and electrodermal activities. We currently have all these sensors in our lab and Polyme. However, so far we haven't made the effort to, let's say, define smart data models for these, and this is something that we also look forward. And finally, something that is also of importance would be to model a human digital twin. Currently, we do have some basic implementation, but I think it needs to be significantly improved in order to make it uh, more realistic. And that was all from my side. Thank you. And I'm open to questions. And if anyone is interested in specifically my group at Polyme, you can scan the QR code here. Or if you want to know more about Made Competence Center, I leave the other QR code as well. Thank you.
Yeah, just question. I'm curious because You said that you are planning, if I understood well, to also upload all this information, and my understanding is this a human digital twin, let's say, details to some form of a blockchain or distributed ledger technology. Did you started to investigate, or you are planning to use
So
some
this is
particular?
something that is already we've already implemented in the P2 code project. So here I was trying to make it more about IoT, just IoT. But yes, there is already an we already have an implementation. And if you want, you can maybe contact me later. We can have, let's say, some sort of a meeting where I can show you how we are basically using that.
Yeah, okay. Maybe we can keep in touch at some point. I'm just curious because I know with the digital twin might generate a lot of information, and
Exactly.
blockchain it's sometimes a bit laggy in
Yeah, so
ingesting and
so
processing.
we
So
actually do not use so I actually only secure very something that changes at a lower frequency. So if I go back, so I only store the baseline values on the blockchain. I know what you mean when you said it is laggy, because I know there is a certain transaction frequency which is associated with the blockchain, and you
Mhm.
can't have, let's say, 1,000 hertz uh, data stream being stored on blockchain.
Mhm.
Okay,
So as
great,
of now,
good.
it is just the most sensitive data that I'm storing there.
Okay, I see. Good, good. Thanks.
Thank you for the questions.